Alright, so on this particular problem, I want to factor 6x squared minus 23x plus 20. And when I look at this, I want to factor it. I look at 6, 23, and 20, and I ask myself, is there a common factor? And there isn't. So that means 6x squared goes here, 20 goes here, and so then you get 6x squared times 20 is 120x squared, and then this is minus 23x. And again, since this is 120 is positive and 23 is negative, the only way that can happen is with two negatives. So now I can tell you already what's going to make this a tougher problem is this 120, because I need to look at the factors of 120 that will give me 23. And if you're really good at these, some people don't necessarily need to work too hard on this part. Some people have to work a little harder. So my strategy is I look at the factors, and I always like to run through and make sure I get them all. So I know 1 times 20 isn't one of them, but it's a process I do. So 2 times 60, 3 times 40, 4 times 30, 5 times, what is that? 5 goes into there, 2, 24, and then 6 times 20. So notice 5 and 24 is 29, 6 and 20 is 26, 7 doesn't go into it, 8 times 15. So 8 plus 15 is 23. So once I get to the factors I need, I stop. And so then this is negative 8x and negative 15x. So sometimes, especially when this number is big, finding the combination is probably the hardest part. So now we plug them into our area model and we get negative 8x minus 15x. What does 6 and 15 have in common? 3. X squared and x, so x in common. So 3x times what gives me 6x squared? 2x. 2x times what gives me negative 8? Negative 4. And then negative 4 times what gives me 20? And so that would be negative 5. Alright, so we're not done with the problem because we want to solve using the zero product property. So 0 equals 2x minus 5 times 3x minus 4, and then we do 2x minus 5 equals 0, and 3x minus 4 equals 0. So we get 2x equals 5, and then x equals 5 halves, and 3x equals 4, and x equals 4 thirds. So these are my solutions.